Alright, so in this section of notes, and so this is notes, it's just a kind of guide for what we've kind of learned already in the last section. So on this day 2, we just want to do a lot more practice on being able to convert from words into the math type. So the idea here is that anytime that you're faced with a word problem, most students end up kind of giving up, and so we don't want to do that. We want to have all of this practice so that we can just kind of go flow right into solving. So you're always looking for those keywords, obviously the numbers, but then those keywords, which I can show here on the lesson. This is the filled in version of what we did the other day for turning words into math, and so you're looking for keywords like takeaway or combined or a multiple. Even though those are very common speaking words, they are also helpful in converting from English to math. So taking a look at this first one here, and you will have a homework assignment that has to do with working through these types of problems. So we're going to write the following in algebraic expression, into an algebraic expression. So notice it says b less than 17. So taking into account this piece right here, remember that if there was anything about less than, you do actually need to turn around what you hear. So we hear less, and so we think subtraction, but then whatever the order was, we need to turn it around. So going back to this original, it does feel like it should be b less than 17, but it's actually going to be 17 taking away b. So again, this feels like it's the answer, but because of the less than, we're going to flip it around, and so we'll actually have 17 minus b. So b is less than 17, so let's take that b away. Alright, the next example is 10 more than y. And so as much as you see more and then than, remember that turnaround is actually only going to be used in less. If you want to, technically you can flip it around, but 10 more than y is actually the same as y and plus 10. Okay, so either one of those can be the answer. So again, 17 minus b for number 1 there, and 10 plus y, or y plus 10. This is because subtraction actually talks about order mattering. For instance, if I have $100 and I'll take away 20 and now I have 80, that's completely different than if I have $20 and I take away 100, which is impossible. Getting some loans there. However, if I add money, so I've got $100 plus another $100, or whatever the sum may be, it doesn't matter which order I add them in, I'm still going to get that same total. So that's what we call commutative. So if you were paying attention to a lot of those terminology pieces in middle school, you probably heard the word commutative, and it just means that you can do it forwards and backwards, and it gives the same result. Alright, so our next piece here is number 3, and we're using quotient, and if you actually look ahead to number 4 as well, they're both the quotient, but one of them is 2 and x, and the other is x and 2. And so anytime that you're working with a quotient or a ratio, you are always reading left to right or top to bottom. Okay, so we never actually go from the bottom up, and we never really read from right to left. So you're always thinking about the order of things. So in this case, we are talking about quotient, which is division, and this is going to be the first piece, and the x is going to be the second piece. So again, we don't do division with a division symbol anymore, we do it with a fraction bar, and so the 2 is the first thing, so it'll be on top, and the x is the second thing, so it'll be on bottom. So that one represents the quotient of 2 and x. The next one, however, notice how it's backwards. It's the quotient of x and 2. So now we put x first, or on the top, and then 2 on the bottom. The next two are actually going to be kind of multi-step. So notice that it has the words the quantity in both of these. This one here is the ratio, so we are going to be talking about division. So it's a ratio of a quantity of 6 more than a number with 7. So if you are familiar with your numerator of the top of the fraction and denominator in the bottom of the fraction, the ratio is going to have 6 more than a number as the numerator, or listed first, and 7 as the denominator. So the grouping is this whole idea of the green piece, where we're doing the quantity of this with 7. So officially, that means that our numerator is going to be the quantity, or in parentheses, 6 more than a number. We don't really know what that is, so variable. And that's 6, not 16. And then the denominator is 7. So this is our ratio answer. And hopefully we are aware that ratios are fractions, and if not, that's your example there. The next one is going to be 8 minus the quantity of the sum of a number in x. Oh, and 8, sorry. So 8 minus, it's going to be very direct, but then it's the quantity, and so that's where we're going to get parentheses because of that word. And then the sum of, so sum is going to mean addition, and then we've got a number, which could be x or whatever variable you want, and then 8. Alright, so 8 minus x plus 8. Lots of 8s going on. Alright, so those are the first types, and again, you will have some of those on the assignment to practice as well. It does go with what we did before, but the more practice you have on this, the easier our word problems will be as we move through the course. So, the next piece is going to be writing an algebraic expression. There are quite a few of these on the assignment, and again, that's because being able to take this scenario and making it into a mathematical statement is really what we're going for here. So apparently in this scenario, Sophie's math class has 6 fewer male students than female students. If there are F female students, we need to write an expression for the number of males in the class. So again, there are 6 fewer male students than female. So again, we see 6, but we see fewer than, and so again, fewer makes you think less, but than means that you need to switch the order. So as much as we think 6 minus female is going to be the amount of male, it's actually female, whatever the total number of females. If we take away 6, that's how many males there would be. So again, this one is taken out because of the word than. We want to flip them around. Alright, the next piece is a computer printer can print 10 pages per minute. Super. Write an expression for the number of pages the printer can print in n minutes. So as we take a look at where the number is, notice that the number is by the word per and then minute. So again, in this case, we're going to be doing 10 per minute, meaning multiplying, or 10m, or parenthesis people, 10m. Okay, so either one of those is our option. Again, how do you know that this per is multiplying versus dividing? And that's where you go into the content. So the printer is not dispersing 10 pages, it's gathering those 10 pages. And so that's where we're going to get multiplying to make it bigger versus dispersing or giving out, which would be dividing. So 10 pages per minute, adding up each minute. Alright. Then our last example here, I like this one the best. Paula always withdraws $20 more than she needs from the bank. So she goes into the bank, she says she needs however much money it is, but then she adds 20 to it. Sweet. So they want us to write an expression for the amount of money Paula withdraws if she needs D dollars. So she goes to the bank knowing she needs D dollars, but then she decides to take away $20 more. So again, $20 more is going to be the fact that we are adding 20 to what she needs from the bank, which is going to be our D. Again, it does say than, and so if you want to, you could also just do 20 plus D, but remember that addition is commutative, so it doesn't quite matter. And then the last piece is actually saying, okay, well, now that you know, let's go ahead and use what we know to solve this problem. So we're going to find the amount of money Paula withdraws if she needs $20, $60, and $75. So if she needs $20, she's going to withdraw 20 plus the D value, which is 20, and so she's going to end up with $40. If she tries to withdraw $60, she's going to end up actually withdrawing 20 plus 60, so $80. If she tries to take out $75, she's actually going to end up with 20 plus the original 75 that she said she would take, and so there's going to be $95 that she will take out. And of course, that's a lot easier if you just add $20 to it, but the whole idea is that you do understand that there is a process of what the expression might be, and then inserting those new values into that process. Alright, so your assignment is going to be very similar to this. Again, we'll have quite a few of these problems up here where you're going to want to make sure you have the order correctly, and then you'll have your scenarios. And there will be one just like this one at the bottom where you'll make your scenario and then use it.